A car traveling at 9 meters per second accelerates at the rate of 0.8 meters per second squared for an interval of 4 seconds. Find the final velocity. This little subscript f tells us that we are looking for that final velocity. So, with our goal approach, we list our knowns and our unknowns first. We'll take this one number at a time, starting with this 9 meters per second. The question says a car is traveling at 9 meters per second, so that's what it starts out with, or its initial velocity. Here at this value, we see the square, and that lets us know that this value is an acceleration. So our acceleration, 0.8 meters per second squared, and we always need to include that square on our units. Our last number is this 4 seconds. That's our time interval. So those are our knowns, and then our one unknown is this final velocity. Now, as with the goal approach, we're going to estimate or assume our final units. Because our initial velocity is in meters per second, we're going to assume our final velocity is also in meters per second. Now, looking at the values that we are given, this will be an average acceleration. Acceleration, by definition, is the rate at which our velocity is changing over time, or how fast we're speeding up or slowing down over time. That's our acceleration. So, the formula for acceleration is the change in velocity, where we do final minus initial, over the time interval given. We always do final minus initial. Regardless of the type of formula you are using, it will always be final minus initial. Now, we don't want to solve for a. We already have that value. Instead, we want to solve for final velocity. So, as part of the goal method, we need to solve this formula in terms of final velocity. Or essentially, we want this value, that value, final velocity, equal to a combination of our other knowns. So I'm going to go through every step of this algebraically. If you are one of those people who can already tell what the formula will be just by looking at it, you are more than welcome to skip these steps. However, if you're a student who is struggling with some algebra, it's really helpful to write this out. So multiply both sides by t first. And then from here we can see it's a simple adding of vi to both sides to get our final velocity. Now I'm going to swap this equation so that our final velocity is on the left, equal to a variation of our variables on the right. And this is standard physics practice, to put what we're solving for on the left and everything else on the right. Now we can just simply plug in numbers, the initial velocity being 9 meters per second, plus the acceleration is 0.8 meters per second squared, multiplied by 4.0 seconds. This will get us an answer of 12.2, and let's double check our units. Here we have a meters per second, that was expected. Here we have a meters per second times second. So we quickly write this out. Meters times second squared times seconds, or seconds over 1. This can also be written as meters over second times seconds over 1. And we see that one of those seconds from the square will cancel. And so we are left with meters per second. And that's the velocity. We have meters per second plus meters per second to give us a final unit of meters per second, which is what we predicted at the beginning with our goal method.